Hello everyone, I am Eamon GR from Sri Venkateswara College of Engineering. Today we are discussing about the topic Dijkstras Algorithm in a analysis and design of algorithm. First we are discussing about what is Dijkstras Algorithm, finding the shortest path. Dijkstras algorithm is a graph search algorithm that finds the shortest path from the starting node to all other nodes in a weighted graph with a non-negative edges weight. It systematically explores the graph, always extends the shortest known path, ensuring that once of the node shortest path is found, it will not change. It widely used in GPS, network routing, and many other fields. Next, we are discussing about properties of Dijkstra's algorithm. First, grid greedy strategy. Always select the next node with the smallest known distance. Non-negative weights only works only with a non-negative edges weight, fails with negative weights. Single source shortest path like find the shortest path for from one source nodes to another source node. Next, we are discussing about problems of shortest path. Goal like a find the path with the minimum total weight. Scope from the source node to all or specific destination node. Applications is like a include route planning and network optimization. Next, we are discussing about algorithm. In that algorithm, input is like a weighted connected graph with a non-negative weights and its vertex. Output the length dv of a shortest path from S to V and ultimate vertex PV for every vertex V. Initially is like a initially is working like a which is used to store and extract the vertex with a minimum tentative distance efficiency, and q is used to determine the next closest vertex of process, and dv means the distance from a side vertex v, and here ds is equal to 0 means the set of distance from the source to itself to 0 because it's already at the source. And next it decrease the key of vertex s in a priority queue to reflect this non shortest distance. Here for I is equal to 0 to modulus v minus 1 means repeat the following step modulus v times once in each vertex. Here d is equal to 0, and deletion q means remove the vertex u u star from the priority queues within a minimum dv value distance not yet finished, and here vt means add vertex u to the set of the visited vt. Here for every vertex v in v u in v means check each unvisited neighbors u of a current vertex u star, and u star du means du is the shortest distance to u. This is the weighted of the edge of the u star to u, and decrease u comma du means after updating and decrease the key of u in the priority queues to reflect the new shortest distance. Next, we are discussing about example for finding the shortest route. This is the diagram or example. First, we have to take node A, B, C, D, E in a graph, and next we have to start with the node A and execution step by step update of distance and result shortest path from A to C is 12. How we discuss next. And we assign all nodes to tentative distance value that will be changed over time. So there we use the table on the right which consists of three column. In the first column we have node, in the second column shortest distance, and third column will be empty because currently we have no information about this. First we calculate all unvisited neighbors of A, and the distance from the A to B is 2, and the distance from the A to D is 8. So we can update out table on the right. We have found the new shortest distance to one of the unvisited nodes, and B and D are unvisited and the current distance is infinity. So we can update distance from A to B and store A in the previous node and in our table, and the same applies to the node D also. We can update the shortest distance to D to the value 8 and with the previous node A. Next we have to find for B. So unvisited neighbors of B are E and D. So since B has the current distance of 2, we need to add this 2 to the weight of the edge to E and D. So now first all the node E will has current distance 8 from A over B, and now we need to check if A 8 is less than current shortest distance that we stored in table, and the current shortest distance we sort in table is infinity, and 8 is less than infinity, so we need to update shortest distance to E and set B in a previous node. Now let's look at the node D. We'll have to distance of 2 plus 5 7 from A over B. This means we need to compare this 7 to our current value 8 in the table, and since 7 is less than 8, we set the current value for the shortest distance to 7 and we set the previous node to B. By following these instructions, we need to do all the unvisited nodes lost the shortest distance from A to C. We get length 12, so that the shortest path. Next we are discussing about use cases in a real world applications is like a Google Map, network routing, and robotics and airline ticketing. Google Maps is routing plan with the real-time data and network routing protocols like OP, PS, and ISIS. Path planning for autonomous vehicles, finding optical flight connections.